Hi everyone, now we're going to take a look at number 10 from chapter 1 of our book. This example will help us understand how everything comes together, how we can actually create the equations, put them together to create the model. So in number 10, it says that we have a retail store in Des Moines, Iowa that receives shipments of a particular product from Kansas City and Minneapolis. We have two variables, x and y, and we are letting x equal the units of product received from Kansas City and y equal the units that we received from Minneapolis. So in part A, we want to write an expression of total units of product received by the retail store in Des Moines. So if we look at the wording here, we are developing an expression, and that expression is going to equal the total units that they get in Des Moines. So we are figuring out what equals the total units. We need to figure out what goes in this box. What do we add together to get our total units received? Well, we know we have two variables that we're dealing with here. And whatever we get from Kansas City, so x, added to whatever we get from Minneapolis, y, is going to equal the total that they get in Des Moines. Part B says shipments from Kansas City cost 20 cents per unit and shipments from Minneapolis cost 25 cents per unit. We want to develop an objective function representing the total cost of shipments to Des Moines. So we want to pay attention to the wording here. The first thing, or what we are looking for, is the objective function, and that objective function represents the total cost. So what is everything going to cost that they get in Des Moines? So what equals the total cost paid by the store in Des Moines? Well, we're told that whatever we get from Kansas City, which we know from the information that we're given, that's x right now, the variable x. Every x unit from Kansas City costs 20 cents per unit. So we have 20 cents times x, the number of units that we get from Kansas City, plus the cost of what we get from Minneapolis. Well, each unit from Minneapolis costs 25 cents, and we get y units from Minneapolis. So while we don't exactly know x and y yet, we can insert the variables, and we have developed our objective function. That brings us to part C. Assuming the monthly demand at the retail store is 5,000 units, we need to develop a constraint that requires 5,000 units to be shipped to Des Moines. So we need to figure out what is going to equal the 5,000 units shipped to Des Moines. Part C is very similar to Part A. Now in Part A, we didn't know the total units. Here we do. We're told that that equals 5,000. So whatever we get from Kansas City added to whatever we get from Minneapolis must equal 5,000 units. That's our first constraint. Then Part D, we're told that no more than 4,000 can come from Kansas City and no more than 3,000 can be shipped from Minneapolis. So we need to develop constraints to model this situation. We need to pay attention to the wording here. It says no more than 4,000 and no more than 3,000. No more than is an inequality. So we need to think back to our algebra days. Less than or equal to, greater than or equal to. We're going to have a constraint for Kansas City and a constraint for Minneapolis. So first let's look at Kansas City. Kansas City, we know, is our x variable. So x, or whatever we get from Kansas City, has to be less than or equal to 4,000. Then similarly, if we look at Minneapolis, that is our y variable. Y variable has to be less than or equal to 3,000. No more than 3,000, or a max of 3,000, can come from Minneapolis. So now, sorry about that, we have our two constraints based on what we can get from each of the two cities. So part E says, of course, negative amounts cannot be shipped. Combine the objective function and the constraints developed to state a mathematical model. So that means we are going to put everything together for satisfying the demand at the Des Moines retail store at a minimum cost. So we need to put everything together now. So what do we know? What have we started with? Well, we know that the total cost is 0.20x plus 0.25y. We also know that x, or what we get from Kansas City, plus what we get from Minneapolis, has to equal 5,000 units. Now we need to bring in our constraints. X, what we get from Kansas City, has to be less than or equal to 4,000. And Y, what we get from Minneapolis, has to be less than or equal to 3,000. We also know, we were just told here, negative amounts cannot be shipped. So that means X and Y have to be greater than or equal to 0. Right? We have to ship a positive number. So all of these combined create our mathematical model. Now what is important here is up here, our top line, that is our total cost. If we scroll back up and look, that was our objective function. So this might be a good spot to remind yourself, that's our objective function. That function will help us calculate our total cost. It is subject to, so ST, subject to these 4 constraints. From here, we can take and either calculate this by hand, figure out what X and Y equal, or we can use Excel and find exactly what should go in each spot. How much should we get from Kansas City? How much should we get from Minneapolis?